We've been asked to find the shaded region in this question. I'm going to split it into two parts. R1, which is this blue part over here, just the area underneath the square root function between these limits. And then R2, this small region here, which is going to be the area underneath this exponential between the limits shown there as well. So first up, I'm going to work out R1. Right, I'm interested in this lower limit. So that's going to be when the square root of 2x plus 9 is equal to 0, which means 2x plus 9 is equal to 0. X is minus 9 over 2. Then R1 is the integral minus 9 over 2, so 0, of 2x plus 9 to the half dx. Okay, it's got to be careful with this integral. So, in fact, I'm going to move over here as a bit more space. Add 1 to the power. Divide by this new power, which is the same as timesing by 2 over 3. And then I'm going to divide by what is in the derivative of what, well, not the, yeah, because it's a linear function, I basically divide by 2 as well. Because when you differentiate this, it's the outside and the inside. So you times by the derivative of the inside. So here I divide by the derivative of the inside to get the half. This is all about integrating functions of the form f of ax plus b. And you always get like a 1 over a coming out. And then whatever your integration is, if it was sine, for example, sine of 2x plus 1 integrated, then it would become also a half here. Maybe I'll change it to a third. It'd become a third. So I change it to 3, so it become a third, and then minus cos 3x plus 1. So I'm using that idea, plus c. As always, it's good to just check back here. So when we differentiate, I would times by 3 over 2, which cancels with the 2 over 3. I would lower the power, now times by the derivative of the inside, which cancels, and we get back to the original. So that is really good. Put the limits in, so 0 minus 9 over 2. The 2 over 3 times the half cancels to leave me just 1 over 3. Put the limit of 0 in, so I'm going to get a third times 9 to the 3 over 2. And then when I put minus 9 over 2 in, remember we already had it that this was equal to 0, so I'm just going to be subtracting 0. So either time for your calculator now, or this one checks out without. 9 to the 3 over 2, you square root to give 3, you raise to the power of 3, 27, divide by 3, 9. That is our value of R1. All right, on to R2. So now we need to find this point here, which is going to be when 4e to the minus 2x minus 1 is equal to 0, which means e to the minus 2x is going to equal a quarter. We can take ln of both sides. Just put a ln there, put a ln there. These cancel, so I'm left with minus 2x is equal to ln of a quarter. Okay, you could leave it as ln of a quarter, but it's just whenever you get ln of a fraction in this kind of scenario, I think it's good to make it get rid of the fraction basically. So a quarter is 4 to the minus 1, and this becomes minus ln 4 then, because you bring the minus down. So what I'm saying really is whenever you have ln of 1 over a, or log of 1 over a, you can just write it as minus ln or log a. And that's going to be useful here. So then x will equal a half of ln 4. I can bring this up and square root it. It's actually just going to become ln 2. It's quite a technical little thing we've got to do there, but that is going to be our upper limit. So now R2 is going to be the integral from 0 to ln 2 of 4e to the minus 2x minus 1. Okay, it's going to work in a similar sort of way to the other ones. So e to the minus 2x integrates to e to the minus 2x, except we need to divide by minus 2, because when you differentiate it, you times by minus 2. So I'm going to get minus 2 here. If you differentiate it, you'll get back to the original. This will become minus x. Right, let's carefully put these limits in. So it's going to be minus 2 e to the minus 2 ln 2 minus ln 2 minus minus 2 e to the 0, which is just 1, and then minus 0. Remember, we've got a 9 up here that we need to add on at the end. And we've also got asked to leave it in this form. We've got the ln 2 going on, so that's good. Minus 2 e to the... Now, in a similar sort of way, this is going to become ln 2 to the minus 2, which is ln of a quarter. That's 2, which is then a quarter, so it's going to be minus 2 times a quarter and minus a half. Which is 3 over 2 minus ln 2. So we are there. The shaded region, shaded area, is going to be 9 plus 3 over 2 minus ln 2. And 9 is just 18 over 2, so it's going to be 21 over 2 minus ln 2. Brilliant.